take this to the nth root. If you're talking about 2 years in a difference of the percentages, then it's to the square root. But if you're talking about 15, then it's to the 15th root. So that's when you need this special calculator. So this is going to pretty much tell me the differences in percentages, ratios, indices. So things that change that I'm saying, okay, the GDP has grown 2% or has dropped 5%. If I have that data for 5 years, then I can tell you the average that it's dropped or risen. Suppose that we receive 5% increase salary and a 15% increase the next year. The average annual increase is 9.886, not 10. Why is this so? If I add this up, 5 plus 15 divided by 2, the average is 10. You see the average is just a little bit off, but if you're talking very specifically, the geometric mean gets it a little bit better. So what I would do would be taking the first percentage times the second percentage, and then in this case taking the square root, because I'm talking about 2 years. If I were talking about 5 years, then I would multiply all 5 of those together and take the fifth root. Like I said, you may have a question on this, but it's not going to be the end-all, be-all of the test. And what that tells me is just an average change over a particular amount of time. Dispersion is how my data is spread out, what it looks like. Is it really concentrated? If I have a very high peaking normal curve, then I know the majority of the students made that middle part. If it's flat, then I know it's kind of spread out. And normal curve is what we're going to talk about throughout the semester. How we measure dispersion, we have the range, we have the mean deviation, and we have the population variance. This population variance and standard deviation we're going to use again throughout the semester. I don't have to do 2 calculations for the variance and standard deviation. All I have to do is calculate one or the other, and one is the square root of the other one. So the variance is going to be the standard deviation squared. So if you're given the standard deviation on the test, hint, hint, and I say what's the variance, square it. If you're given the variance and I say what's the standard deviation, take the square root. That's an easy in-class test question, and I will have the blank stares because I don't remember any of this and I don't know this formula. I won't ask you to memorize the formulas for the in-class test. This is what I'm looking for, that you know the relationship between the variance and the standard deviation. So the range, and this is what it's getting with the example I gave you earlier. Sometimes data is not represented in a way that's useful to us. Sometimes the range works, but sometimes it doesn't. And sometimes the average works and sometimes it doesn't. The range is just the smallest and the largest subtracted. These bars right here mean absolute value, which means that I don't care if it's negative or positive. I just want it to be a value. All I care about is the number of spaces, not if you're going backwards or forwards. So whatever your answer is for the range, it should always be positive. The mean deviation is just the average that it deviates from that mean, that it goes away from the mean. So for this one, I have these values of from the previous example, Starbucks location. They track the number of cappuccinos that were sold for these 5 days. I want to figure out the mean deviation. So the average that each one is deviating from this mean. So first I need to figure out what the mean is, add them all up, divide by 5. I get an average of 50. The easiest thing for me to do, and if it's yours, that's great, make a table, because you keep everything straight. You're going to use this data again throughout, so you may want to refer back to a certain column. So I want to figure out how much it deviates, so 20 minus 50, 40 minus 50, and so on. If I add these up, because remember, in this formula, for the average deviations, it wants you to add them up. What happens if I can get it over there, what happens if I add these up in the middle? See, yes, 0. I'm trying to see if I can see this on the video. It equals 0. So 0 divided by 5 is not helping us at all. So I want to get, again, the absolute deviation from the mean. So 30, 10, 0, 10, and 30. And these should be reflective of each other. This should be like a mirror image. And then I have that it's 80. 80 divided by 5 is 16. So the average day deviates from the mean 16 cappuccinos, or whatever they're talking about. Variance is going to be the arithmetic mean of the squared deviations from the mean. This is Greek right now. It means nothing, but it's going to mean something later on. And all the standard deviation is just the square root of that. So what I'm doing is I'm taking each value, subtracting the mean, and squaring it. I add all those up and divide by whatever number I have. So like I said, a table is going to be the easiest thing for most of you. First step, I want to calculate the mean. The second step, I want to set this up in a table so it's easy for me to, and you won't have data sets this big, most likely, so you should be okay. But I want to subtract each one of these, the mean from each one of these. Again, if I add these up, this equals 0, so it's not really one I want to deal with, but I do want to square these, and then I can use the values, and they're all added up, and it doesn't equal 0. So I take each one of these values right here, this x minus the mean, all the way down, and I square each one of them. I make a different table. Now in the formula it asks you to add these up, sigma of the x minus the mean squared. So I'm going to add all these up, and then I divide by 12. That's the number of data sets that I have. They're talking about months, it's going to be 12. So I take this 1488 divided by 12, and it should equal 124. That's my variance. My standard deviation is just going to be the square root of that. If I have a sample variance, and this is where sample and population, the formula changes just a little bit, I'm just going to be dividing by n minus 1. It only changes it just a little bit. So for the homework, it's just practicing these problems to know how to calculate it. Right now, it doesn't mean anything to you. It will mean something to you later on. Sample variance, an example, I have these sample problems. The same thing. I subtract the mean from each one of my x values. I square them, and I add them up and divide by, instead of n, it would be n minus 1. And it only changes the value just a little bit. Chekhov's theorem, for any set of observations, the proportion of the values that lie within k standard deviations of that mean is at least 1 minus 1 divided by k squared, where k is a constant. Okay, really confusing definitions. Let's go through the example. Arithmetic mean of biweekly amount contributed by this paid company employees to the profit sharing is 5154, standard deviation of 751. At least what percent of the contributions lie within plus 3.5 standard deviation or minus 3.5 standard deviation points? Right now, we'll worry about just calculating this, but we're going to be dealing with this normal curve again throughout the semester. All the way through chapter 12, we're dealing with this normal curve. And when we talk about standard deviation points, we're talking about the number of lines that you go over. I think there's not one. So I'll draw it out for you. All normal curves are going to look like this. This may need to warm up. No, it doesn't. All normal curves are going to look like this, and all of them are going to have standard deviation points set at 1, 2, and 3. And this is going to be standard for all the problems that we're doing. They assign values here for 100, 110, 120, and so on because of what the problem says, not because of anything that's going to be standard. So let me just introduce this a little bit. I think this is the right one. I guess I hope I take that off. Watch it not work. It's worked every semester. Please turn off the projector. Okay, it's not going to work. So, okay. Now if I can get it back. Okay. So what this is saying is this is 1 standard deviation point out, this is 2 standard deviation points out, and then this one's 3 standard deviation points out. And that 99.7% of my data should lie between this 3 and -3, which is where the 70 is. And this is standard for all normal curves. And we'll go through several examples of that. This is just kind of an introduction to it. So if I tell you that the standard deviation for something is 10, then that means I'm adding 10 for each one that I go over. And then I'm subtracting 10 for each one that I go over. In just a second, I'll see if I can get the projector to work after I reset it. And we'll go through an example. The arithmetic mean of grouped data. Remember we talked about last week that we need to figure out what the midpoint is for classification. So if I have an age range that I'm talking about. Do you fall within this age range? I need to figure out what the middle point is to figure out what the average is. So here, we use this in chapter 2. We talked about the average selling price of these cars. And I need to figure out what the midpoint is for each one of these classes to figure out what the mean is. I have no idea of figuring out what the average is here. I have no idea because I don't know, were all these cars 15,000 or were all of them 8,000 or 18,000? I have no idea. So I just kind of estimate according to the midpoint. So I figure out what the midpoint's going to be, and that's in this column right here. And what I do is I multiply this 8 times the 16.5 and the 23 times the 19.5 and so on. I add all of those up and divide by 80. There were 80 cars. And that tells me an approximate average according to this frequency, or according to this group data for the frequency. Standard deviation of group data, it's similar to how we just calculated it. I might have you doing one homework problem on this, but we're not really dealing with group data as much as we are with the raw data. We'll have that to be able to do these calculations. So here I have all the classes. I take the midpoint minus that average that I came up with, square it, add them all up, and divide by, or multiply by the frequency. So I'm doing the exact same thing that I did before. It's just a different example. Let me see. I thought it went through an example. I guess it doesn't.